In this problem, we are asked to find the angle subtended by a line segment at the vertex of a parabola. The line is given by the equation 3x minus 2y plus 12 equals 0, and the parabola is given by 4y equals 3x squared. The line intersects the parabola at 2 points. Let's call them A and B. We need to find the angle formed by the line segments connecting the vertex of the parabola to points A and B. First, let's find the coordinates of the intersection points A and B. We can rewrite the line equation to solve for y. Adding 2y to both sides gives 3x plus 12 equals 2y. Dividing by 2, we get y equals 3 halves x plus 6. Now, substitute this expression for y into the parabola equation for y equals 3x squared. This gives us 4 times the quantity 3 halves x plus 6 equals 3x squared. Distributing the 4, we get 6x plus 24 equals 3x squared. Rearranging this into standard quadratic form, we have 3x squared minus 6x minus 24 equals 0. We can simplify this by dividing the entire equation by 3, resulting in x squared minus 2x minus 8 equals 0. Now, we factor the quadratic equation. We are looking for two numbers that multiply to negative 8 and add to negative 2. These numbers are negative 4 and positive 2. So, the factored form is x minus 4 times x plus 2 equals 0. This gives us two possible x values for the intersection points x equals 4 and x equals negative 2. Now, we find the corresponding y values using the line equation. Y equals 3 halves x plus 6. 4x equals 4. Y equals 3 halves times 4 plus 6, which is 6 plus 6, equaling 12. So, point A is 4, 12. 4x equals negative 2. Y equals 3 halves times negative 2 plus 6, which is negative 3 plus 6, equaling 3. So point B is negative 2, 3. Next, let's find the vertex of the parabola. The equation is 4y equals 3x squared. We can rewrite this as y equals 3/4 x squared. This is a parabola in the form y equals ax squared, centered at the origin. Therefore, the vertex V is at the point 0, 0. Now, let's visualize the situation. We draw the coordinate axes. We plot the parabola y equals 3/4 x squared, which opens upwards with its vertex at the origin. We plot the line y equals 3 halves x plus 6. We mark the intersection points A 4, 12, and B negative 2, 3, and the vertex V 0, 0. We are interested in the angle AVB formed by the segments VA and VB. Finally, let's calculate the angle theta equals angle AVB. We can use the slopes of the lines VA and VB. The slope of a line passing through the origin 0, 0, and a point, x, y, is simply y divided by x. The slope of line VA, let's call it m sub VA, is 12 divided by 4, which equals 3. The slope of line VB, m sub VB, is 3 divided by negative 2, which equals negative 3 halves. The tangent of the angle theta between two lines with slopes m1 and m2 is given by the absolute value of m1 minus m2 divided by 1 plus m1 times m2. Now, substitute the slopes into the formula. Tangent theta equals the absolute value of 3 minus negative 3 halves divided by 1 plus 3 times negative 3 halves. The numerator simplifies to 3 plus 3 halves, which is 9 halves. The denominator simplifies to 1 minus 9 halves, which is negative 7 halves. So, tangent theta equals the absolute value of 9 halves divided by negative 7 halves, which is the absolute value of negative 9 sevenths, or simply 9 sevenths. Therefore, the angle theta is the arctangent of 9 sevenths. So, the angle subtended by the line segment AB at the vertex of the parabola is the arctangent of 9/7.